your C, little a minus VO2. So if we take 19 minus 19 minus 14.
So the VO2 max would be 250?
Okay, so your VO2 max, you get is 156, because it's 130 times 1.2. I'm going to write it really big so that I can show y'all the equation.
Oh, okay, because I had looked at an equation that where I got the formula from, and it said 125. So then I guess it's 130.
Either of those, like your answer would have been close enough.
Mm-hmm.
So,
Okay.
yeah.
Okay.
Let's see what y'all can see. Okay. And you see it.
I can't see anything.
Can you see my formula?
No.
I can't see it.
No. No.
I can kind of see it.
I can't see anything.
Does that say BP times BSA?
I think 130 times BSA.
130 times BSA.
I guess it's the same way I have the formula, because I had 125 times BSA. So you do 130 times your BSA over your divided by the CA minus VO2. Over 5, right here. Yeah. Then you get your 31.2.
Now you should be able to see it then.
That's perfect.
So your top, your VO2 max is 130 times your BSA, which is 1.2. Bottom, your A minus VO2, 19 minus 14.5. We can multiply that by 10. Gives you 50. Do the math for your CO2 max, it's 156. You divide 156 divided by 50, you get 3.12 liters per minute. Pretty good on that?
Yep.
Okay.
What about number 7?
$6.17 liters.
Very good.
Could you round or do you just keep it as 6.17?
You can round, like if they gave you the answer of 6 liters per minute, that would be good, right? You also, when you do the math, you probably got 6,175. If you
Yes.
put in that, you need to make sure that you put the right unit, which would be ml, okay? Make sure that you know that you could be given that in either form.
Okay.
ml, milliliter per liter. All right, what about number 8? Stroke volume equation.
I got 75 milliliters. Do you just convert the 6 liters into milliliters and then divide by the heart rate?
Yeah, so you actually leave it in liter form. So if you divide times 6 divided by 80, you get 0.75 liters or 75 ml, because that one always needs to be in ml.
Okay.
If you want to go ahead, like do it in liter or switch it before, that way you don't have to move decimals, you could do 6,000.
Okay.
Yeah, you could do 6,000, so put it in ml, go ahead. 6,000 divided by 80 would be 75. And if you get really wonky numbers on that one, a really easy way to remember it is if you're getting these massive 500, 1,000 as your answer, is it possible for your heart, which pretty much fits in your hand, right, to squeeze out a liter of fluid at one time? Absolutely not. Okay? So sometimes when you're doing these math equations, you just need to think, is that physically possible? Okay?
Right.
That's a good trick also when you're doing like mechanical ventilation and stuff like that, and you're talking about volumes for mechanical ventilation. Is that possible to fit in somebody's lungs at one time based on their size? Okay? All right. Number 9. What did y'all get for 9?
3.
I got 3 as well.
And I got 3.
Very good. What is your units on that one?
Liter per minute per meter square.
Very good. Liters per minute per meter squared. What about number 10? What did y'all get?
1.4 millimeters of mercury. And multiply by 80.
Yeah. So what did y'all get?
1.4 times 8.
112
dimes per second per centimeter.
Yeah. 112.
Yeah.
So what everybody got? There's more.
Yes.
One. That one. Okay. Your normal for that, normal value for your PVR is 50 to 150. So this would be a normal. What about number 11, your SVR?
1,120.
Very good. 1,120.
Yeah.
Normal value on SPR, 800 to 1,500. And that is times second centimeters. Right, what about
You
number
said 1,600, right?
1,500 if you're high end for SBR, 1,500. All right, what about number 12? What did y'all get?
I got 247.95. I just rounded
Very,
248.
round that to 248, very good. Just a little side note, what's going to happen to your P big AO2 if your FiO2 and your barometric pressure goes down? P big AO2, are they going up or down? That.
I would assume down.
Very good. So just remember, if both go down, your barometric pressure and your FiO2 go down, your P big AO2 should also go down. What's something that's going to change? What's something that's going to cause your barometric pressure to go down? In what cases?
Elevation. Like if you're in a different, like if you versus like if you live in Jacksonville versus the mountains or something.
Very good. So high altitude.
High
is what
altitude.
that barometric pressure down. Okay. Opposite effect of that, if someone wants to go below sea level, so diving, their barometric pressure is going to go up. Okay. All right. Number 13, AA gradient. What did y'all get?
300.
What is my shunt percentage?
That's asking two different things, right? So
Yeah. So calculate your AA gradient and estimate the physiological shunt. So what's my AA gradient?
300.
300. And then what is my shunt?
Is it 15%?
I got pretty close to that. I've got 12.
Oh,
12%.
So let's see, how did you get yours?
I just figure, like out of like each 100, you should have like a 5% shunt, and then I just multiplied 3 times 5, the 3 from the 5.
Pretty close. How I like to do it is you take your AA gradient, divide it by 50, and then
So
multiply that by 2.
50, and then multiply by 2. Okay.
So 300 is my gradient. I divide that by 50. I get 6. 6 times 2 is 12%.
Okay.
I think that's a little bit easier.
Okay.
Right, number 14. What did y'all get for your PF ratio?
Is it 87.5?
Yes. And what
Is that right?
Yeah.
That indicates the severity of ARDS.
Right. So what's
With,
the
like,
classification there?
Less than 100 is severe. So it's
What value? Above what?
excuse me. It needs to be
normal value. What do you want it to be?
Above, is it 450? Or, yeah, isn't it 450 to
300?
Oh, 300.
300. Okay. So anything above normal, anything above 300 is normal. ALI is 200 to 300. Anything less than 200 is art. All right. Number 15. What did y'all get? We're calculating the arterial oxygen content.
0.2872. I don't even know if that was right.
Nope.
I got 10.9.
Yeah, I
Very
got
good.
10.9 as well.
Okay. Right, so let me write this
No,
down.
it is. I think I did get 10.9, but I don't know where I put it.
So then write
Okay, yeah.
Right. Can you see it, Flo?
No, I can't see it.
Can you now?
No, every time you put something up, I see somebody else. Like right now, I see it.
Click on my image. Can everybody else see it?
I can see
Yeah.
it.
I
Okay, now I can see it.
Okay.
Okay. Okay. I guess I did my own indifference HB times 1.
Somebody tell me what your normal value is for arterial oxygen content.
Is 16 to 20
Okay.
percentage.
Yeah. 16 to 20 is your normal arterial oxygen content, and it reflects your overall oxygen carrying capacity for your arterial blood. Okay. So you good?
I did it like the other. I had did the 0.003 times the PaO2 plus the 1.35 or 1.34 times the hemoglobin times the saturation of oxygen. Just the placement, I did it different. So I did get that 10.72, but I got it as 0.1072. That's why it was like.
All right, number 16, calculate the mixed venous oxygen content.
$21.76.
I'm sorry.
21.76.
All right, anybody get anything else?
I got 11.36.
11.36 is correct.
Okay. I guess it was just the placement as well, because I did it exactly how the other.
Right, it's the same formula. So just plug back in your numbers. watch out if that SVO2 or SaO2 what's getting you.
No, it's just I've always done the formula the same exact way, and I've never had a problem. I've always done it with the 0.003 times the PaO2 plus your 1.34 times the hemoglobin times the saturation. I've never gotten it. I've never had an issue with it now until now.
That's the correct formula. So something's going on with your math. Are you not moving your decimal? From like for number 16, SVO2 is 70%, but you have to put that in decimal form. So it's 0.7.
That's what I did with the top two, and that I don't know. That's why I'm getting it wrong. I don't know.
4 years up real quick.
I don't know. I'll just go over him again.
I'm gonna look at it. I want to make sure that y'all are. The point of this is to make sure everybody is good with this. So I don't want you to not feel confident going into tomorrow. So, all right, or on Thursday. All right, so your 0.003 times your PbO2 is good. Yep, that's what you're doing, I think. You are multiplying, you're doing something wrong in your multiplication of the 1.34 times your hemoglobin. So it should be 1.34 times 12 times 0.7. I don't know where you're getting the math mixed up because you didn't write that part all out, but there's something there. So you're writing the formula correct, but the math is wrong.
Okay.
Okay? Because it should be, if I take 1.34, I take 12, hemoglobin 12, multiplied by 1.34, that's 16.7, multiplied by 0.7, it's 11.256. Where you're getting.
Okay, I think what I did too, as you can see it at the top, changing that hemoglobin instead of just using the number, because it says percent, changing that into a decimal.
Yeah,
that's what it was.
Yes.
Yeah, because I did it at the top too. And the only one that's supposed to be changed to the decimal is the saturation. Correct.
Correct.
Okay, I think that's what it was.
Okay. Good. That's not a hard fix.
Okay.
All right, number 17. What do we get?
Is that 3 volume percent?
Very good. Pretty simple. You just subtract your small v from your small a, so 17 minus 14, 3 volume percent. All right, number 18, what do we get?
I got 2.
I got 2.
Is it 200?
200. So actually, the body surface area is not relevant here, right?
Yeah.
So if we take five and multiply it by our percentage, wait,
0.4.
times 0.4, 100, let's get 200.
Five times 0.4.
Yep,
5 times 0.4 is 2, right?
yep. Multiply that by 100,
Okay.
200 milliliters per minute.
Okay.
Normal
I did-
vacuum for
Okay, so I did that totally different instead of about 200.
how did you get it?
I did, I changed that instead of like before, I didn't do 0.4, I did 5 times, 0.04, which I got 0.20 times that by 10, and I got the 200. I don't even know how I did that, but let's go with that.
So many different ways to do these. As long as you're getting the right answer, I can't tell you that the formula sounds like you're using the right number. That might have been something you need to pick up from Persing, because I know he does some shortcuts.
No, I found it on another packet of calculations.
Okay. What is your normal VO2?
Didn't you say with that max was 30?
Normal is 200 to 350.
Oh, okay.
What can increase your VO2?
Would it be your FI? VO2.
What did you say, Flo?
No, I'm thinking of because your VO2, not your oxygen consumption.
Uh-huh.
That would be whatever your FiO2 is on, right? Or no?
No. So oxygen consumption is going to be caused by the oxygen dissociation curve. So
Okay.
fever or you're exercising, then that
Oh, okay.
need for oxygen is going to be increased.
Okay.
VO2 max is going to be higher in people with a fever, sepsis, any kind of infection, or if you're exercising, okay? Depending on your exercise tolerance. All right, number 19. What did you get?
Mm. 0.085.
Okay, that answer is correct, but this should be in percentage form. So what would it be in percentage form?
Is it 8.9?
9%.
8.6%.
8.6.
Normal value for QSQT is less than 10%. Doing okay, everybody? All right. Number 20, calculate the oxygen index or OI index for a 6-month-old on pressure control ventilation. What is my oxygen index?
I got 46. I don't know if that's right.
Yes, very good. Oxygen index. What does it mean for this patient?
Above 40 is extremely severe.
Very good. And the recommendation in the ECMO. So remember, oxygen index is used kind of like PF ratio or RSBI, anything like that. It is a tool that they can use to see the severity of something, to kind of gauge how they're using their oxygen, if it's efficient. So if 0 to 25 is good, the good oxygen index that indicates that the patient does not need to be elevated in care. 25 to 40 is going to tell you that that patient has an increased risk of death in about 40%. And if it's over 40, you need to consider ECMO. Through this, let's take like 5 minutes, come back and finish this out, okay?
Okay.
Okay, thank you.
Mommy, out I got.
Hmm.